Hi and welcome to Apex Atlas. Far from the continents, separated by wide oceans and deep time, lies an island unlike any other on Earth. This is Madagascar, an island where evolution took its own path, where forests became laboratories, where animals and plants transformed in isolation, untouched by the forces shaping the rest of the world. Madagascar broke away from Africa more than 100 million years ago, and from India soon after. Since then, it has drifted alone, a world apart. As a result, over 90% of its wildlife exists nowhere else on Earth. Lemurs replaced monkeys. Baobabs towered where forests vanished elsewhere. Frogs, chameleons, insects, and plants evolved in endless variation, each adapting to the island's shifting climates and landscapes. In this documentary, we explore the complete natural identity of Madagascar, its ancient origins, its dramatic landscapes, its unique wildlife, and the fragile balance that now determines its future. This is not just an island, it is a living arch. Eve of evolution, the island that time forgot. To understand Madagascar, you must begin with separation. More than 160 million years ago, Madagascar was part of the supercontinent Gondwana, connected to Africa, Antarctica, and India. But tectonic forces slowly pulled it away, first from Africa, then from India. When the final break occurred, Madagascar was left alone, completely isolated, while other landmasses collided, folded, and reshaped. This island remained geologically quiet. No massive mountain chains rose skyward. No young volcanoes dominated the land. Instead, Madagascar aged. Erosion softened its highlands. Rivers carved deep valleys. Plateaus formed, then slowly wore down. This geological stability became its defining feature. As climates shifted across the planet, Madagascar's isolation prevented species from migrating in or out. Life already present on the island had only two choices: adapt or disappear. Rainforests clung to the eastern slopes, fed by moist air rising from the Indian Ocean. In the west, seasonal dry forests evolved to survive months without rain. In the south, spiny deserts emerged, harsh, thorn-covered landscapes found nowhere else on Earth. Each region became its own evolutionary experiment, without competition from large placental mammals. Small ancestral species diversified rapidly. Lemurs evolved into dozens of forms, from tiny nocturnal hunters to large, ground-dwelling forest giants. Plants adapted just as dramatically. Baobabs developed massive trunks to store water. Succulents grew armor-like spines. Forests learned to shed leaves, then regrow them quickly when rains returned. Madagascar became a place where specialization ruled. But specialization comes with vulnerability, because once isolated systems are disturbed, recovery is slow, sometimes impossible. The island's landscapes appear timeless, yet they balance on fine ecological margins. What makes Madagascar extraordinary is the same thing that makes it fragile. It is not simply old. It is unique. And every forest, valley, and plateau holds life shaped by millions of years of isolation. Life that exists nowhere else on Earth. This is the island that time forgot. And very thing that follows flows from that separation. A land of contrasts, climate and seasons. Climate shapes everything on Madagascar, despite its single island form. Madagascar contains some of the sharpest climate contrasts found anywhere in the world. Rain, wind, and elevation divide the land into distinct natural worlds, often separated by only a few hundred kilometers. Along the eastern coast, warm air rises from the Indian Ocean and is forced upward by the Central Highlands. As it cools, moisture condenses, delivering heavy rainfall year after year. This side of the island is defined by abundance. Rainforests remain green even in the dry season. Rivers flow year-round. Mist hangs in the canopy at dawn, feeding mosses, orchids, and ferns that depend on constant humidity. Move westward, and the climate shifts dramatically. The highlands act as a barrier, blocking much of the incoming moisture. Rainfall decreases. Seasons become more pronounced. Here, dry deciduous forests dominate. Trees shed their leaves during the long dry months, reducing water loss and slowing growth. Life enters a state of waiting, conserving energy until the rains return. In the far south, conditions become harsher still. Rain is unpredictable. Temperatures are high. Soils are poor. This region supports the spiny desert, a landscape of thorny plants, succulents, and drought-adapted life, found nowhere else on Earth. Seasons in Madagascar are defined less by temperature and more by rainfall, from roughly November to April. The wet season brings intense downpours, swollen rivers, and rapid plant growth. From May to October, the dry season settles in, cooler and calmer, with many ecosystems slowing almost to a standstill. But rainfall is rarely gentle. Madagascar sits directly in the path of Indian Ocean cyclones. Each year, powerful storms can strike the island's eastern coast, bringing destructive winds, flooding rains, and landslides. These events reshape landscapes in a matter of hours. Forests are torn open. Rivers carve new paths. Sediment flows from mountains to sea. Yet life here has adapted to instability. Plants regrow rapidly. Animals adjust breeding to seasonal cycles. Ecosystems recover, provided they are given time. Climate variability also drives migration. Birds move with the rains. Lemurs shift their ranges in search of fruit. Insects emerge in vast numbers during brief windows of abundance. But this finely tuned balance is increasingly strained. Climate change is intensifying rainfall in some regions, while extending droughts in others. Cyclones are becoming stronger. Dry seasons last longer. For an island built on specialization, these changes carry serious risk. Madagascar's climate does not offer uniformity. It offers extremes: wet and dry, lush and sparse, calm and violent. These contrasts shaped the island's ecosystems, driving the extraordinary diversity that defines it today, and they continue to decide where life thrives, where it waits, and where survival hangs in the balance. Rainforests, dry forests, and spiny deserts. Across Madagascar, distance alone does not define difference. Rain does. From one coast to the other, a shift in rainfall creates entirely separate worlds, each with its own rules for survival. Along the eastern edge of the island, rainforests rise where moist air from the Indian Ocean meets the central highlands. Here, water is rarely absent. Tall trees form dense canopies. Vines climb toward filtered light. Ferns, mosses, and orchids cling to trunks and branches, drawing moisture directly from the air. These forests remain active year-round. Fruits ripen in sequence. Insects thrive in constant warmth. Animals move through layered habitats, from forest floor to canopy, each level supporting different life. But these rainforests are narrow. Step inland, and conditions begin to change. Rainfall decreases. Seasons sharpen. Western Madagascar is dominated by dry deciduous forests, ecosystems built on patience. For much of the year, trees stand leafless, their branches bare beneath intense sun. Growth pauses. Energy is conserved. Then the rains arrive. Within weeks, the forest transforms. Leaves return. Flowers bloom. Insects emerge. Animals feed and breed rapidly, timing their lives to the brief window of abundance. This rhythm, long restraint followed by sudden growth, defines much of the island's interior. Scattered among these forests stand the baobabs, massive, slow-growing. Their swollen trunks store water for dry months ahead. They are living reservoirs, able to endure conditions that would kill other trees. Each species of baobab evolved separately, rooted to specific regions, unable to spread far beyond them. Further south, even dry forests give way to something more extreme: the spiny desert. Rain here is scarce and unreliable. Temperatures remain high. Soils offer little nourishment. Plants respond by armoring themselves. Thorns replace leaves. Succulents store moisture in thick stems. Growth is slow, but survival is efficient. Animals adapt in parallel. Many are nocturnal. Others rely on highly specific food sources. Movement is minimal. Every action conserves energy. These ecosystems are among the most unique on Earth, and among the most fragile, because specialization leaves little room for change. Between forests and deserts, Madagascar's landscapes shift again. Limestone plateaus rise in the west, carved by water into razor-sharp pinnacles known as zisingi. Soils collect only in crevices. Roots cling where they can. Yet even here, life finds a way. Plants grow sideways along rock faces. Animals navigate narrow stone corridors. Entire communities exist in spaces that seem uninhabitable. Together, these landscapes form a mosaic. Rainforests capture moisture, Dry forests wait. Deserts endure. Rock forests cling to survival itself. Each system evolved independently, yet all remain connected by climate, water, and time. This diversity is Madagascar's greatest strength and its greatest vulnerability, because when forests are cleared or rainfall patterns shift, these finely tuned systems struggle to adjust. What makes Madagascar extraordinary is not simply the presence of these ecosystems, but how sharply they change, sometimes within a single day's journey. On this island, nature does not fade gradually. It transforms completely. Highlands, rivers, and hidden valleys. At the heart of Madagascar rises a backbone of ancient land. The Central Highlands stretch from north to south, forming a plateau broken by rolling hills, deep valleys, and isolated peaks. These uplands are not young mountains, but worn remnants of a landmass shaped more by erosion than upheaval. Here, elevation changes everything. Temperatures cool. Rainfall patterns shift. Rivers are born. Moist air rising from the eastern coast condenses as it meets the highlands, feeding countless streams that cut their way through the plateau. Some flow east, racing quickly toward the Indian Ocean. Others drift west, meandering across dry plains before eventually reaching the Mozambique Channel. These rivers shape life far beyond their banks. They carve fertile valleys where soils collect. They transport nutrients from mountains to lowlands. They create corridors of greenery through otherwise dry landscapes. In the highlands themselves, human and natural systems have long intertwined. Terraced rice fields follow the contours of the hills, holding water during the wet season and releasing it slowly during drier months. These terraces mirror natural floodplains, demonstrating how water management evolved alongside the land. Hidden within the folds of the plateau are valleys that remain cool and moist year-round. Here, fragments of forest survive, refuges for species that once covered far larger areas. Mist lingers in the mornings. Streams run even during dry months. These pockets of stability are vital. They allow plants and animals to persist. When surrounding landscapes become hostile, they serve as stepping stones for movement across the island. Waterfalls mark the transition between highlands and lowlands, plunging from elevated plateaus into dense forests below. Each drop of water carries sediment, slowly reshaping both riverbeds and coastlines over time. Yet these systems are vulnerable. Deforestation on slopes increases erosion. Rivers fill with sediment. Flooding becomes more destructive downstream. As climate patterns shift, rainfall becomes less predictable. Some rivers dry earlier each year. Others surge suddenly, overwhelming landscapes that once absorbed seasonal flows. Despite this, Madagascar's rivers remain lifelines. They connect distant ecosystems. They sustain agriculture and wildlife alike. They bind rainforests, dry forests, and deserts into a single island system. The highlands do not dominate Madagascar visually, but they quietly control its water, its fertility, and its resilience. Without them, the island would fracture into disconnected worlds. With them, life continues to move. D. Own valleys, across plains, and out to sea. Creatures found nowhere else. Isolation is the architect of Madagascar's wildlife. Cut off from the rest of the world for more than 100 million years, Madagascar became a laboratory of evolution, a place where life followed paths unseen anywhere else on Earth. Nowhere is this more evident than in its mammals. Madagascar has no native monkeys, no large cats, no hoofed grazers. Instead, the island belongs to lemurs, descended from a small ancestral population that arrived by chance. Lemurs diversified into dozens of species, each adapted to a specific niche. Some leap between tree trunks using powerful hind legs. Others move slowly, conserving energy in sparse forests. Some are active by day, others by night, their large eyes tuned to darkness. Together, lemurs fill roles occupied elsewhere by monkeys, deer, and even small predators. But mammals tell only part of the story. Reptiles flourish in Madagascar's warmth. Chameleons evolved into extraordinary forms, some no larger than a fingernail, others capable of changing color with astonishing speed and precision. Their eyes move independently, scanning the world in near-perfect awareness. Geckos cling effortlessly to rock and bark. Snakes and lizards specialize in narrow habitats, many found only in a single valley or forest fragment. Amphibians rival this diversity. Frogs come in countless shapes and colors, their calls filling forests after rain. Some carry toxins. Others rely on camouflage so precise, they vanish against leaf litter. Insects dominate quietly. Butterflies pollinate rare plants. Beetles recycle nutrients. Ants and termites engineer soils, shaping landscapes from the ground up. Even Madagascar's top predator is unique. The fossa, a sleek, agile hunter, moves through forests with ease, capable of climbing, leaping, and ambushing prey. It occupies a role found nowhere else, perfectly adapted to hunt lemurs in three-dimensional space. What unites all this life is specialization. Species evolved to thrive in very specific conditions. A certain forest type, a particular altitude, a narrow climate range. This makes Madagascar astonishingly rich and extremely vulnerable. When forests are cleared or climates shift, species cannot simply move elsewhere. For many, there is nowhere else to go. Yet survival continues. Some animals persist in small refuges. Others adapt to secondary forests. Conservation programs work to protect habitats before they fragment beyond repair. Madagascar's wildlife is not defined by size or strength. It is defined by originality. Each species represents a unique solution to survival, shaped by isolation, time, and chance. Lose them, and the world loses something it can never replace. On this island, evolution did not just branch, it flew shed in forms found nowhere else on Earth. Fire, cyclones and survival. In Madagascar, nature is not gentle. It is dynamic, seasonal, and at times overwhelming. Fire, storms, and floods shape the island's landscapes as surely as geology and climate, testing every species' ability to endure change. Fire has long been part of Madagascar's environment, particularly in dry forests and grasslands. Some ecosystems tolerate occasional burns. Plants resprout from protected roots. Seeds germinate in cleared soil. Grasses return quickly after flames pass. But unlike fire-adapted systems elsewhere, many of Madagascar's forests evolved with limited exposure to intense fire. When burning becomes too frequent, recovery slows, then stops. Repeated fires prevent trees from regrowing, transforming forests into open grasslands, and exposing soils to erosion. Much of this burning is human-driven, used to clear land or manage pasture. When combined with longer dry seasons, fires spread further and burn hotter than ecosystems can withstand. Cyclones bring a different kind of force. Each year, warm waters of the Indian Ocean generate powerful storms that sweep toward Madagascar's eastern coast. Winds tear through forests. Rain falls in torrents. Rivers swell and overflow. In a single night, cyclones can undo decades of growth. Trees fall. Hillsides collapse. Sediment rushes downstream, clouding rivers and smothering coastal reefs. Yet cyclones are not purely destructive. They redistribute nutrients. They open forest canopies, allowing light to reach the ground. They trigger regeneration. If ecosystems remain intact, flooding follows closely behind. Rivers fed by highland rains spill across lowlands, recharging soils and wetlands. Fish breed in newly connected waters. Seeds spread across floodplains, but as forests disappear upstream, floodwaters become more violent. Without roots to hold soil, erosion accelerates. Fields are buried. Waterways choke with sediment. Survival in Madagascar depends on timing. Plants grow fast when conditions allow. Animals breed opportunistically. Many species live on the edge of scarcity, waiting for brief windows of abundance. This adaptability has allowed life to persist through centuries of instability. But the rhythm is changing. Cyclones are growing stronger. Dry seasons are lengthening. Fires burn more often. Ecosystems once able to recover between disturbances are now struck again before healing is complete. Still, resilience remains. In protected forests, trees regrow. In managed landscapes, fire can be controlled. Where rivers are allowed to spread naturally, floodplains recover. Madagascar's nature does not resist disturbance. It responds to it. The difference between survival and collapse lies in frequency, intensity, and space. Give ecosystems time, and they endure. Take that time away, and even the most ancient systems begin to fail. Coasts, reefs, and the Indian Ocean, where the land of Madagascar meets the sea, another layer of life begins. The Indian Ocean surrounds the island on all sides, linking forests, rivers, and reefs into a single living system. What happens inland is carried outward by water, sediment, and nutrients, shaping the coast in subtle and powerful ways. Madagascar's shoreline stretches for thousands of kilometers, ranging from sheltered bays to exposed cliffs and wide sandy beaches. Along much of the western and northern coasts, coral reefs form shallow barriers just offshore. These reefs are smaller and less continuous than the Great Barrier Reef, yet they are no less important. They support thousands of species: fish, mollusks, crustaceans, and corals, many found only in this part of the Indian Ocean. Reefs act as breakwaters, reducing wave energy and protecting coastal communities from storms. Between land and reef, mangrove forests take root. Their tangled systems of roots trap sediment, stabilize shorelines, and create nurseries for young fish and invertebrates. During storms, mangroves absorb floodwaters, reducing erosion and damage inland. Further offshore, seagrass meadows spread across shallow seabeds. These underwater grasslands anchor sand, store carbon, and provide food for turtles and dugongs. Together, reefs, mangroves, and seagrass form a connected chain. Damage one link, and the others begin to weaken. The Indian Ocean itself is a driver of life. Warm currents bring nutrients and larvae from distant regions. Seasonal changes influence fish migrations and breeding cycles. Whales pass close to shore on long-distance journeys, using Madagascar's waters as feeding and resting grounds. But the ocean also delivers pressure. Rising sea temperatures stress coral, leading to bleaching events that weaken reefs. Stronger cyclones batter coastlines more frequently. Sediment from deforested hills smothers coral and seagrass, blocking light and slowing growth. Overfishing adds further strain, reducing populations faster than they can recover. For many coastal communities, the sea is inseparable from daily life. Fishing provides food, income, and identity. When marine ecosystems decline, human vulnerability increases alongside ecological loss. Yet resilience is still present. Marine protected areas are expanding. Some reefs recover when given respite. Mangroves regenerate quickly if cutting is reduced. Sustainable fishing practices are restoring balance in targeted regions. Madagascar's coasts are not boundaries. They are transitions, places where land and ocean negotiate constantly, where rivers meet tides, where forests feed reefs, and where storms redraw the edge of the island. To protect the sea, the land must be protected too, because in Madagascar, every hillside, every river, and why forest eventually flows into the Indian Ocean. Humans and the forest. For thousands of years, people have lived within the landscapes of Madagascar, not apart from nature, but dependent on it. Madagascar was one of the last major landmasses settled by humans. When people arrived, they encountered forests, rivers, and wildlife found nowhere else on Earth. From the beginning, survival required adaptation to a land of contrasts. Forests became central to daily life. They provided timber, fuel, food, medicine, and shelter. Wild plants supplemented crops. Animals were hunted carefully, often guided by cultural rules that limited overuse. Agriculture evolved around the island's rhythms. In the highlands, rice terraces followed valleys and slopes, holding water during the wet season and releasing it slowly as rains faded. Along forest edges, small clearings supported crops suited to poor soils, but pressure grew as populations expanded. One of the most widespread practices became tavi, slash-and-burn agriculture. Forest is cleared and burned. Nutrients released briefly into the soil. Crops planted for a few seasons. Then land abandoned as fertility declines. For centuries, this cycle worked at low population levels. Given enough time, forests regrew, but as fallow periods shortened, recovery slowed. Forests fragmented, soils eroded, grasslands replaced once diverse ecosystems. Today, many communities remain closely tied to forests, not by choice, but by necessity. Limited access to alternative livelihoods means wood is still used for cooking, land is still cleared for food, and forests continue to shrink. Yet this relationship is not purely destructive. Across Madagascar, community-based conservation is reshaping how forests are managed. Local groups protect woodland, regulate harvesting, and benefit directly from sustainable use. Where communities gain secure rights to land and resources, deforestation slows, forests stabilize, wildlife persists. Traditional knowledge plays a crucial role. People understand seasonal cycles, soil limits, and the behavior of plants and animals in ways refined over generations. When combined with scientific support, these insights guide restoration, fire management, and sustainable farming. The future of Madagascar's forests cannot be separated from the future of its people. Conservation that ignores human needs fails. Development that ignores ecological limits fails just as surely. Balance lies in between. Forests are not empty wilderness. They are lived-in landscapes, shaped by hands, knowledge, and survival. Whether they endure will depend on whether people are supported to live with the forest, rather than be forced to live from its destruction. Nature under pressure. For millions of years, the ecosystems of Madagascar evolved in isolation, slowly, precisely, and with little margin for disruption. Today, that margin is shrinking. Madagascar is now one of the most biologically rich places on Earth, and one of the most threatened. The greatest pressure is deforestation. Large areas of forest have been cleared for agriculture, fuelwood, and grazing. What were once continuous ecosystems are now fragmented into isolated patches, separated by grassland, fields, and roads. For species adapted to narrow habitats, fragmentation is as damaging as destruction. Populations become trapped. Genetic diversity declines. Local extinctions follow. Soil erosion quickly compounds the problem. Without tree cover, Rain strips fertile topsoil from hillsides, carrying it into rivers and wetlands. Fields lose productivity. Waterways clog with sediment. Flooding becomes more destructive downstream. Rivers that once ran clear now turn brown after heavy rain, transporting the evidence of land loss all the way to the sea. Coastal ecosystems feel the impact. Sediment smothers coral reefs and seagrass meadows, blocking sunlight and slowing growth. Combined with warming ocean temperatures, this stress leaves reefs increasingly vulnerable to bleaching. On land, wildlife faces mounting pressure. Many lemur species now survive in shrinking forest fragments. Hunting, even at low levels, can push already small populations beyond recovery, because so many species exist nowhere else. Losses here are permanent. Climate change amplifies every threat. Dry seasons are becoming longer and hotter. Rainfall arrives in shorter, more intense bursts. Cyclones grow stronger, damaging forests already weakened by fragmentation. Ecosystems once able to recover between disturbances are now hit again before healing is complete. Yet pressure does not fall evenly. Some regions retain resilience. Protected forests slow deforestation. Community-managed lands show lower rates of degradation. Marine reserves give reefs time to recover. The difference is not geography alone. It is choice. Madagascar's nature is under pressure not because it is fragile, but because it is specialized. These systems evolved for stability, not speed. They cannot simply move, adapt, or rebuild overnight. What happens in the coming decades will determine whether Madagascar remains a global sanctuary of unique life, or a record of what once existed. Under pressure, the island's ecosystems are being tested. What remains uncertain is how much time they are given, and whether that time is enough. The future of Madagascar's wild places. The future of Madagascar has not yet been decided. Despite the pressure facing its forests, reefs, and wildlife, this island is not a lost cause. It is a turning point. Across Madagascar, conservation is no longer focused only on protection, but on partnership. National parks now safeguard many of the island's most critical ecosystems. From eastern rainforests to western dry forests and southern spiny deserts. Within these protected areas, species still persist, ecosystems still function, and natural processes continue largely uninterrupted. But parks alone are not enough. The future depends on what happens beyond their boundaries. Community-led conservation is proving one of the most powerful tools for change. When local people are given secure rights to manage forests, deforestation slows, illegal logging declines, wildlife has space to recover, reforestation projects are restoring degraded land, using native species adapted to local conditions. These forests do not grow quickly, but they grow with purpose, rebuilding soil, water cycles, and habitat at the same time. In coastal regions, mangrove restoration is protecting shorelines from storms, while supporting fisheries and livelihoods. Marine protected areas are allowing fish populations to rebound, strengthening food security for communities that depend on the sea. Science and traditional knowledge increasingly work side by side. Researchers monitor species and climate trends. Communities apply generations of understanding about land, seasons, and limits. Together, they guide decisions grounded in reality, not idealism. Climate change remains the greatest challenge. Some habitats will shift. Some species will struggle. Losses are likely unavoidable. But the scale of that loss is still within human control. Madagascar's ecosystems have survived tectonic separation, climate shifts, and millions of years of isolation. What they cannot survive is speed. If forests are given time to regrow, if rivers are allowed to recover, if reefs are spared repeated stress, life here can endure. The future of Madagascar's wild places will not be shaped by a single solution, but by thousands of small decisions. How land is farmed, how forests are used, how oceans are fished, and how value is placed on nature itself. This island is more than a hotspot of biodiversity. It is a reminder that once lost, uniqueness cannot be replaced, and that when protection, knowledge, and opportunity align, even the most fragile ecosystems can still have a future. Madagascar is not simply a place on a map. It is a world shaped by separation, by oceans, by time, and by evolution taking its own path. From rainforests older than memory, to deserts armed with thorns, from mist-filled highlands, to coral seas along the Indian Ocean. This island holds life found nowhere else on Earth. But uniqueness carries responsibility, because what disappears here is not replaced elsewhere. The future of Madagascar will be decided not by nature alone, but by human choices. How forests are protected, how oceans are respected, and how communities are supported. If you've enjoyed this journey through one of the planet's most extraordinary natural worlds, please like the video. It really helps support the channel. And subscribe to Apex Atlas for more in-depth documentaries exploring the nature, geography, and stories of countries around the globe. New places, new stories, the same planet. Thank you for watching, and we'll see you in the next destination.